Hi, for this video what I want to do is show you how to find the amount that is left in an account after interest has been compounded at a certain rate. So what we have here is we have $5,000 is being invested in an account earning 4.5% interest. Find the balance after 5 years compounded in the following ways. And the reason I'm doing the same situation with the same beginning amount, the same interest rate, and the same time is so you can see how each of the following ways of compounding does influence the results. Okay, so there are two compound interest formulas. There's the traditional compound where the ending amount is equal to the principal, which is the starting amount, times 1 plus the interest rate as a decimal, divided by the number of times per year that it's compounded, to the n times t. So you're going to use this one if it says things like annually, semi-annually, monthly, daily, etc. N would just be the number of times. So like annually would be once per year. Monthly would be 12 times per year. Quarterly would be 4 times per year. Semi-annually is twice per year. Daily is 365 times per year. Okay, the other one that is used in compound interest is continuously compounding interest, where it's being compounded all of the time. And for this one, we use A equals P, which represents the principal, times E, which is Euler's number. This is programmed into your calculator, to the RT, where R is your rate as a decimal and T is your time in years. Okay, so what we're going to do is we're going to look at all of these where we have our starting amount is 5,000, so this would be my principal. My R would be this rate right here, but I have to write it as a decimal, so this would be 0.045 is the rate that I would put in. And then this would be our T. Okay, and then so for each situation that we have below, we will look at the different n's. So for annually, n would equal 1. That means once per year you would compound it. Okay, so with this, what we would do is we would put the amount equals, P would be the 5,000, times 1 plus my rate, which is 0.045. And I don't have to divide by n because if I divide it by 1, it's just going to be 0.045. And then when I put it up here, the n, because I'm plugging in 1 again, I don't really need that, so I can just plug into my calculator to the 5th power, which simplifies things. Okay, it doesn't matter what calculator you plug this in. You will need one that you can do exponents. You can do this on your cell phone calculator. You just have to be really careful when dealing with exponents that if it doesn't automatically put it in an exponent, that you do put it in parentheses if you're multiplying. Okay, I'm just going to use my TI-84 graphing calculator, but again, you could use any calculator. So you would just put in the principal, 5,000, and then you would open your parentheses, 1 plus 0.045, close your parentheses, and then for your exponent, you would use the caret key to the 5th power, and then you would just hit enter. So your balance would be $6,230.91. I'm going to round to 2 decimal places because we're talking about money, and money, it makes sense to round to 2 decimal places. So let's go ahead and write that answer down. So annually, our ending amount would be approximately $6,230.91. Okay, so let's see what happens to it if I compound it more often throughout the year. Okay, so the next situation we have is monthly. So this means that every month it's compounded. So we're still putting in the same amount, so we're still starting with 5,000, but instead of only once per year, now we're going to do it 12 times per year. So we would set this up as 0.045, and this time our n would be 12 because it's monthly. So I would divide this rate by 12. You don't get the full 0.045, you get 1/12 of it every time that it compounds. And then I would put it up here, NT would be 12 times 5. And this is where you have to be careful because of the fact that if your calculator doesn't automatically put it in like mine does, where if it just does like the little caret, you have to put this part in parentheses, or else it'll take it to the 12th power and then multiply the final answer by 5. So be very careful about putting this into your calculator correctly. So with this one, again, we would do the same thing. And if you want to, you can hit second enter on most calculators, and you can just type in the last thing, or you can just start over. If you need to insert something in, you can hit second and the delete. It'll allow you to insert. So I can put divided by 12. And then I can go up into my exponent, and again, I can enter and put 12 times 5. So that way I don't have to retype everything, but it really doesn't matter. You can retype it. Okay, notice now everything else was the same except for the 12. So because we compounded it 12 times per year, that means that we compounded it a total of 60 times over 5 years, since 12 times 5 is 60. So notice that we ended up with an additional $28. So the more times per year that something is compounded, the larger the amount is going to be. So for this one, we would write down $6,258.98. So our amount would be approximately $6,258.98. So the more times per year that something is compounded, the more money that you will earn on that account. Okay. Most savings accounts, they compound it quarterly, so I did want to make sure that I addressed this one. With quarterly, what this is saying is that your in is going to be 4. So for this one, again, the only thing that changes is that instead of compounding it once per year like we did annually, or 12 times per year like we did monthly, we're now going to compound it 4 times per year. So I would set this up as 0.045 divided by 4 to the 5 times 4. So now on the last one, it compounded a total of 60 times. This one will only compound 20 times over 5 years. This one only compounded 5 times. That's why it was so much smaller. Okay, so for this one, what we're going to do is, again, I can just do the same thing as last time, but what I'm going to do is I'm going to change this to a 4, and then I'm going to delete the 2. And I'm going to come up here and I'm going to delete the 1, and I'm just going to change the 2 to a 4, make sure that it is entered in correctly. And then I'm going to hit enter. So I have $6,253. So notice that we earned about $5 less when it was 4 times per year versus 12 times per year. Okay, so it's not a significant difference, but the more money you have in, the more you're investing, obviously, the more it's going to have an impact. Okay, so for this one, let's go ahead and write down the amount. So the amount for this one would be approximately $6,253.75. So the last one is the maximum that it can compound. The continuously compounding interest means that it's constantly compounding, okay? And it's the largest amount that you can possibly get. So with this one, what we are going to do is we're going to use the continuously compounding interest formula. Like I said, it's this formula for continuously compounding. Okay, so what we would write down is we would take the amount equals, the principal's still the same, the 5,000, but now we're going to use Euler's number, which is programmed into your calculator. It's an irrational number. It's approximately 2.71828. So it's in your calculator already. I'll show you how to find it in just a second. And then we would put it to the RT, where the rate is in the exponent and the time is also in the exponent. Okay, so if we plug this into our calculator, we would plug in 5,000. And this time I'm going to hit second and the natural log. There's an e to the x. That is Euler's number. It's already programmed in there. And then I would put in the 0.045 times 5. And so this is the maximum that you can earn at this interest rate. So the $6,261.61 would be your amount after continuously compounding. Okay. So with this, there's a couple things that impact how quickly this grows. One of them is the time. The longer you leave it, the more it's going to grow. If I changed the time to 10 years, it would get a lot more than what it is now. Notice that we started with $5,000 on all of these, and this is just extra money. We didn't put anything else into this account. We just ended up gaining interest on it. So for like this one, we gained $1,230.91 in interest. For this one, we gained $1,258.98 in interest. So this is just additional money on top of what you already put it in. So when you're looking for accounts to put your money into, you do want to look to see the highest interest rate that you can find. Also, how many times per year it is compounding. The more times per year that it compounds, the more money in interest that you will earn. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics you need me to cover, please let me know that as well. And if you get a chance, please subscribe.